Plastic is a problem that happens all over the world. It pollutes the land, the air, and even the sea. But how to stop this plastic problem from continuing? Well, here is one of those solutions. Bioplastic. But what is this bioplastic made out of? Well, the main ingredient to make it is cassava peels. Yes, cassava peels. But what's the decision to make this, and can it be made from scratch? Find out in this video. Kairos, which means the right moment to act. As plastic pollution becomes an important problem that needs to be solved, people must act as quickly as possible before it goes bad. If people don't act quickly, then when will be the right moment to act? This video will be explaining the process of making bioplastic from cassava peels and our act to spread awareness. In everyday life, plastic waste sounds familiar to our ears. Isn't that right? Use of plastic for human needs, from household needs and buildings to our daily needs, cannot be separated from the plastic. According to growmedia.com, plastic waste is waste that is difficult to decompose because it takes a very long time. Environmental pollution due to plastic is one of the pollutants that Indonesia is currently experiencing. According to the National Waste Management Information System, or SIPSN, plastic waste accounts for 18.1% of the various type of landfill waste generated in Indonesia, which means that the use of plastic waste in Indonesia is still fairly large, and many people still use plastic in their daily activities.
Many do not realize that the use of plastic waste has a big impact on the environment. Plastic waste can contaminate soil, groundwater, and underground creatures and reduce soil fertility. Marine animals die because they make plastic waste their food, and decomposer animals die because of the pollution from plastic particles. Humans can also be exposed to microplastic because the use of plastic in everyday life is considered normal, and the added chemicals in plastic can have an impact on health problems such as cancer, birth defects, immune disorders, and developmental and reproductive effects. With so many impacts of plastic waste on the surroundings, there are many efforts to reduce these impacts, such as bringing your drinking bottles, not using plastic straws, bringing shopping bags every time you shop, recycling, and making bioplastics. In this experiment, the bioplastic was made from cassava peels. Because it has a fairly high starch content, it also decomposes quickly and is environmentally friendly when used as a bioplastic material.
The ingredients that are needed to make this bioplastic are grinded cassava peels, cassava flour, glycerin, acetic acid, and water. The tools and devices that are needed are a pan to put all the mixture, spoon to stir the dough and measure the glycerin and acetic acid, electric stove to cook the dough, scales for scaling ingredients, filter for filtering the flour, and also a tray for molding the dough. Before starting to make this bioplastic, the ingredients and tools mentioned before need to be prepared. Let's start. First, grind the cassava peels through a food processor until it becomes a fine powder. After that, scale the grinded cassava peels and cassava flour. The measurements for cassava flour is 123.8 grams and for grinded cassava peels is 78.6 grams. Pour the flour into the pan. Then add 5.3 tablespoons of glycerin and 10.6 tablespoons of acetic acid into the pan. Next, measure 907 milliliters of water, which will later be poured into the pan.
During the process of making this mixture, there are some electrolytes in it. Well, the solution of cassava peel and acetic acid in the mixture contains electrolytes. Electrolyte itself is a solution that can conduct electric current. It could conduct electricity because there are free ions from the solution of a molecule. There are cation ions and anion ions. Acetic acid is CH3COOH, in which there are CH3COO, which is acetate, and H, which is hydrogen. CH3COO is an anion and H is a cation. But they don't dissolve completely, so it is considered as a weak electrolyte. HCN in cassava is also a weak electrolyte, H as a cation and Cn as an anion.
Apart from that, 3 different solutions were tested. While submerged in the mixtures, the litmus paper changed colors. Litmus paper changes colors based on mixture's pH levels. Here, the litmus paper changed to a lighter shade of green, which means the mixture contains electrolytes. First, the cassava powder solution was tested and it was discovered that the mixture is acidic, close to neutral. Then, the cassava powder solution was mixed with acetic acid and the result is acidic. Finally, the acetic acid was tested and the result was acid.
From the usage of electric stove, electricity was used to turn it on. From electricity, it is converted to thermal energy that is used to heat the dough. But what is energy to be exact? Energy is a resource that can be used to perform some activities. Electrical energy is used for some electrical tools, such as lamps, televisions, computers, and the other tools. And in this case, is an electric stove that is used for making our bioplastic dough. The power used to power the electric stove uses watt as the International System of Units standard unit of power. That's why 300 watt at first and 200 watt after that were used when making the dough. In this making process, 0.25 kilowatt hour were found from 300 watt and 0.05 kilowatt hour were found from 200 watt. And by the way, this kilowatt hour was found from watt times hour. So it's like 300 watt times 5 divided by 60. Electrical energy uses joule as the International System of Units standard unit of energy. 90,000 joules were found from 300 watt and 18,000 joules were found from 200 watt. The formula to get this is power times by time. After that, calculate that with the electricity price, which is 1,699.53 rupiah per kilowatt hour. So it's like 424 rupiah from 0.25 kilowatt per hour and 84 rupiah from 0.05 kilowatt per hour. So the price that is used for an electric stove is just 508 rupiah.
If the dough isn't condensed enough, keep stirring and add a little bit of flour into the dough. If the dough already looks like this, then it's already done and ready to mold. Put the dough in the tray. Make sure it's enough to cover the whole tray and it's not too thin but not thick. If it's too thin, it will rip easily. And if it's too thick, it won't be flexible. After spreading the dough on the tray, dry it under the sun for about 3 days until it dries. If it's already dry, they can be peeled off the tray and the result is like this.
The amount of bioplastic that has been produced is directly affected by the amount of cassava peels that was used. For the making of bioplastic, 78.6 grams of grinded cassava peels were used and the amount of bioplastic that was produced is 220 grams, which means 1 gram of cassava skins can produce 2.79 grams of bioplastic. From that data, an exponential graph of the effect of cassava peels weight on bioplastic weight can be made. One of the characteristics that can be found from the graph is that the curve is monotonically increasing. As the weight of cassava skin increases, so does the weight of the bioplastic, which means the heavier the weight, more cassava and bioplastic being used and produced. And from the graph, the equation to find the y-coordinate on the graph was able to be made, which is y equals 3.5603 Eulers to the power of 0.2303 times x.
The bioplastic that has been produced can be turned into a bag and pouches, and here it is. And by the way, this bag and pouches are handmade. Decorated the pouches with colorful buttons and threads, while for the bag, chains are used like this. And studs were installed so the bag can be closed. From here on out, an educational activity about bioplastic was decided to be made, but to promote this activity, a poster is needed with all the information about the activity, and a logo so people can recognize and differentiate the product from the others. The poster was made fairly simple. Top part has a title, taglines, and the logo of the group activity and the school logo, while the middle part has a brief explanation of our activity and information about when and where it will take place. At the bottom, there is a contact for people that have further questions about our activity. With the main picture of the poster are people who are making bioplastic and some additional decoration around the poster. Then, the poster was promoted through WhatsApp and social media. Through WhatsApp, a message was spread with all the activity details and a poster attached to it. At the end of it, there is a list where people can register for the activity. Social media was used to spread the message and to inform people about the ongoing problem.
A presentation and a sharing session was delivered to several grade 8 junior high school students about cassava peel, bioplastic, and our earth plastic problem. They actively asked questions and seemed interested in this product. The results of the bioplastic were also shared at the end of the activity. Then, some students were interviewed at our school about their thoughts and knowledge about bioplastic. Let's take a look, shall we?
Halo, thank you udah mau di-interview. Boleh sebutin nama dan kelas?
Saya Naya dari kelas 74.
Ya, aku Grisel dari kelas 71. Aku Ursula dari kelas 71. Pertama nih, kamu tahu nggak sih atau udah aware nggak sih sama masalah plastik di dunia ini?
Iya, udah.
Iya, udah. Terus apa nih kira-kira yang bisa kamu lakuin?
Saya lakuin sih nggak buang plastik sembarangan dan mengurangi penggunaan plastik.
Ini ada plastik dari singkong. Kalian udah tahu nggak sih ada plastik kayak gini? Nggak tahu sebelumnya. Nggak pernah ya?
Jadi plastik ini tuh lebih gampang terurai. Biasanya kalau plastik butuh bertahun-tahun ya buat terurai. Kalau plastik ini cuma butuh 4-6 bulan doang buat terurai. Jadi ini ramah lingkungan.
Keren. Dan kita mau ngasih plastik ini buat kalian. Oke. Thank you udah mau di-interview.
Makasih.
Semoga lebih aware sama masalah plastik ya. Thank you. Makasih.
The core values of Servium, service and totality, are shown through this project. Serving others by giving information about our cassava peel, bioplastic, and raising awareness about our earth plastic problem. Our product is able to be produced because of our precision and teamwork. Trying various ways, even if it fails, it didn't stop us from trying again. In the end, the bioplastic was able to be made successfully and able to be shared to public. Our hope is that through this action, it can help to overcome the problem of plastic pollution on Earth, because the journey of 1,000 miles begins with one step. Thank you.